my puppy. It's puppy time, Ruby. Are you having fun? Ruby's a little scared. Ruby's 12. And Ruby's here to watch me. No, she's not. She's going to go upstairs in just a minute. Right, Rubes? Ruby is not my dog. Ruby is my wife's dog. So if my wife was here, she'd be licking her and be petting. Me, she just kind of tolerates me. Right, Rubes? You just tolerate me. Right? Okay, so goodbye. Goodbye. Have fun doing math. Okay. Hold on. I got to say goodbye. Okay, I'm back. That was pre-haircut Ruby. So she's getting a haircut this afternoon and a bath. So maybe I should have waited until after her haircut and a bath. She might have been a little bit cuter. But she's still cute. Anyway, let's talk about graphing systems of equations. Solving system of equations. Graphically, this is kind of easy. My name is Mr. Key. What the heck does that say? Man. Okay, my name is Mr. Krause. You can call me Mr. Answer K. 1.9. This is Unit 1. Day 9. We're getting close, kids. Solving systems of equations graphically. You know this. This is from 9th grade. It's where they hit each other. They hit each other here at the point 0, 1. And they hit each other here at the point -2, -3. And just to kind of make it look all pretty, you should probably put it in curly brackets. All right, let's talk about this one. 0, 2, and 2, 0. Oh, man. And then this one's kind of crazy. Parabola in a line. Let's always see what we got. -1, -5. That's like got to be right behind my head. And then 4, 0. So it's a good thing I'm just saying it. Put them in curly brackets, and that's what you got, right? Pretty straightforward, not a big deal. It's just the intersection. It's just where they hit each other. So it's just the intersection points. Just the intersection points. Oh, and just write them as a point, x comma y. Now, yesterday we found out when f of x equals g of x. Remember, when I do this, we're really just looking for the x values. But now I want the points of intersection. So we can use our calculator to do this. It's relatively straightforward. For example, in this case, it's also going to turn out to be a decimal. So I want to find out the points of intersection of this. Now, you should know this is going to be 2 lines. And it's relatively straightforward. Let's get over to the old calculator. And we'll go into graph mode. And let me do this. Put those up there. Okay. And then my 2 functions are y equals 2x minus 1. 2x minus 1. Now, the second one is not ready to be graphed. And it used to be a problem. Like I would have had to divide, I would have had to graph, bring the x over and divide by 3. But the nice thing about these calculators is I can simply just backspace and choose 6 relation. You can just punch in the number 6 or just down arrow to 6. And now I just type it in exactly as it appears. It's sort of a nice little cheat on this calculator, a nice little feature of this calculator, I guess you might say. You're clearly cheating the math on this, but right now we're just trying to find the points of intersection. So there they are, and that's not, I'm not teaching you 9th grade math. I'm teaching you just kind of how to use your calculator in this case. So what we'll do is we want to find that point of intersection. So we're going to go menu, analyze graph, and then intersection. So I click, and there it is. 1.9, 1.29. I don't know why that's coming up like that. 1.29 comma, here's 100th, 1.57. Now that rounded the nearest, but if you right click on it and choose, right click on it and choose, Anyway, I guess I thought you could change what those points are. Somehow you can. I'm not really worried about it. I'm not going to be that crazy about that. Let's do another one real quick. I'll put that up there at the top. We'll get rid of this one. We'll start with a fresh screen. This one's the absolute value of x minus 4. So we know this is kind of a V-looking thing that got moved down 4. Don't forget what you've learned already in this year. Boom, there it is. And then I press tab. And I do 4x minus 2. Now, both of these are set up as y equals, so I can just graph them pretty quickly. And then there's the point of intersection. We'll find that by doing menu, analyze graph, intersection. Click on the left. All doesn't matter where this is. You just kind of create a gray area clicking on the left of this point of intersection and then just dragging to the right until you get there. And then negative 0.4, comma 3.6, negative 3.6. All right, points of intersection. Very straightforward. On the graph, it's pretty easy. Graphing stuff's easy. We're going to do more with that later on when we do some better and higher level graphing stuff. Right now, what we're going to do is just a review of algebra. I just think you should be able to do this. This comes up on Regents exams once in a while. So if you have two equations, your job is to just get rid of one of the variables. In this case, I'm just going to get rid of y. So I'm going to multiply this through by 2. Now, why did I do that? Because 2 times negative y would give me negative 2y, and then these, when I put them together, cancel each other out. And that's my goal. That's what I want to happen. So what I'll do is I'll come over here and I'll rewrite these. So the first one doesn't get changed. And then this one I can become 3x. Oh, excuse me, we're multiplying through by 2. Don't forget, everything gets multiplied through by 2. So this is 6x minus 2y equals 4. And then here I get 8x equals 20. That's weird. So x equals 20 over 8, which is really just 5 over 2, 5 halves. So x equals 5 halves. That's a weird answer, but sometimes you get fractions in this class. Oh, so embarrassing. I should just rewind this and go back, but I just checked my answer key that I had earlier, and I made a mistake. Did you see it? It's a common mistake. 2 times 4. I forgot to multiply, and I even said it, multiply everything through. 2 times 4 is 8. So now it's not 20, it's 24. And 24 divided by 8 is 3. All right, so now that I have x equal to 3, what I'm going to do is I'm going to take a look at the two equations. And I like this equation because it's all positive. So I'm going to do 2x plus 2y equals 16. And then I'm going to stuff in that x. So 2 times 3 plus 2y equals 16. This is really a 6. I mean, I don't need to put a 6 there. I'm just going to subtract 6. I get 2y equals 10, or y equals 5. And there's your two answers, 3 comma 5. So the answer, or the point of intersection for this is 3, 5. Now, there is another way to do it. For those of you that are really, really smart, pause that if you need to. I'm just going to erase it. For those of you that are really, really smart, and some people see this right away, and it's kind of a cool thing, and some people don't. But I could take this whole first equation, write it over here, and divide by 2. Because if I took each of those and divided by 2, I'd end up with x plus y equals 8. And then I do 3x minus y equals 4. And you notice by doing that, the y's just cancel. So I end up with 4x equals 12, or x equals 3. So that's another way to arrive at the first number right there. All right, let's take a look. All right, so what you need to remember is you need to have everything lined up properly. Lined up. Everything gets lined up. So I know the y's are on top, the x's are on top, the numbers are on top, but you see the equals, they're not on top of each other. So everything is. Here's the easiest way to do it. Make sure you have the variables on the left and all the numbers on the right. So in this case, I need to move this over, and I need to put it right there. And this is positive on the right side, so when I slide it over to the left, it'll be negative. So I'm going to rewrite the first one. So the first thing I'm going to do is try to get these things lined up before I even think about changing anything. And then notice there's still a negative 2 on that side. Be careful of the signs. All right, so what I'm going to do is I'm going to take this second equation, and I'm going to multiply through by negative 3. Because if I had a negative 3 here, these two would cancel. Now remember, everything, now like I just did, everything gets multiplied through by negative 3. So the first equation I'm not touching. Can't touch this. Can't touch this. What do we got? Negative 3y. Oh, yeah. Plus 6. Be careful. Negative times negative is positive. and then equals positive 6. Again, negative times negative. Goodbye. I end up with positive 3x equals 15. So x equals 5. Wham. Wham a damn a damn. Damn da ding dang dang doom. And then I'm going to go back and I'm going to look at see which equation is easier to work with. Oh, the second one, clearly. I already have y equals. So I'm going to write y equals 3x minus 2. I'm going to take that 5 and stuff it in there. So y equals 3 times 5 minus 2. 15 minus 2 is 13. Why did I just do 5? Oh, kids. I wish I didn't make mistakes. I wish I was so good that I didn't make mistakes. Do you see this 2 here and a 3 here? What am I doing? It's 2x minus 2, 2x minus 2. So this becomes 10 minus 2, which is 8. So the answer to this equation is the point 3, 5, 5, comma 8. 5 we got over here, and 8 we got here. All right, kids. I know I've made a couple of silly, kind of crazy mistakes. They weren't done on purpose. It's just because I was lacking focus. These kinds of questions, the algebra isn't so much difficult. It's just the focus, okay? All right, remember, we've got to line everything up. So see how I got x's and y's, y's and x, and it's a kind of a mess. So what I'm going to do is I like to stay away from negatives. I'm just going to move this y here because that makes my life easier. It's not changing sides, so it just stays positive y. But positives are easier to move around than negatives. And then the second equation, I'm going to write y minus x equals 3. Now, since I don't like dealing with negatives, I'm just going to take this whole second equation and multiply through by positive 2. So my first equation doesn't get changed. Y plus 2x equals 5. The second equation becomes 2y minus 2x plus, equals positive 6. Equals positive 6. And this pen's terrible. We'll go to black. The x's go, and I get 3y equals 11. Divide by 3, and I get y equals 11 thirds. So my first glance, I'm like, okay, that's got to be wrong. But I'm actually pretty sure that's correct. All right, no big deal. 11 thirds. All right, I want to find x. So I'm going to go, okay, y minus, I don't like negative. I don't like the fact that it's negative x. That's bothersome. So I'm going to do this one. 2x plus y equals 5. Now remember, y is really 11 thirds. And then I get 2x equals. Now, if you can't do that on your head, you just come over here to your calculator and say, hey, dumb machine, hello, dumb machine, help me out. I need some help. 11 minus 11 thirds. And you get 4 thirds. So this is 4 thirds. And then divide by 2. Divide by 2, you get 4 over 6, or x equals 2 thirds. Don't believe me? Just come over here and hit divide by 2. And you get 2 thirds. All right, so there's your answer. 2 thirds, comma 11 thirds. All right, we got one. Let's do this one. So not everything's lined up. So let me get everything lined up. Y plus x. Whoop, the second equation. I'm going to deal with the first equation. I'm just going to change that to x plus y equals 1. Just kind of move this here. It's not changing sides of the equation, so it still stays positive. And then 3x minus y equals 3. Already have opposites. That's nice. I get 4x equals 4, or x equals 1. This equation is easier to deal with because it's all positive. So y plus x equals 1. Y plus 1 equals 1. Y equals 0. So this answer is 1, comma 0. If you were to graph them, they would intersect at 1, comma 0. All right, I got to pause. I'll be right back. All right, so we're going to solve this one graphically. We're going to use our brain to solve this one. So let's look at this one. By the way, whenever you're going to graph something, you should give me some information about it. So in this case, I know my vertex is 6, 1. And it's going up. And it's got a slope of 1. So this one's actually pretty easy. 6, 1. 1, 2, 3, 4, 5, 6, 1. And it hits the corners of the boxes. All right, now I'm going to graph this one. It's not ready to graph yet. I got to move this 2x over. So you get y equals negative 2x plus 6. Y-intercept of 6. 1, 2, 3, 4, 5, 6. Now, was that the line I was supposed to hit? Nope. So, be careful. I don't like this. So at this point, oops, I should be doing this in black. So, oops, I don't know why I went that direction. That was dumb. Just goes back up. Okay, so that's that. And then let's go back to pink. So pink says down 2, left 1. Down 2, left 1. Down 2, left 1. I cannot go down and right when I draw. And then, oh, up 2, left. Oh, there's where it hits. Up 2, left 1. So, and again, you can use your calculator to check this. We might do that in a second. I cannot go that direction. Boom, boom, boom. So it looks like that's my point of intersection, which is negative 1, comma 1, 2, 3, 4, 5, 6, 7, 8. Negative 1, comma 8. But I'm going to check that using my calculator because it's really easy to do. It doesn't take me more than about a minute to do. I just go into graph mode. Absolute value of x minus 6 plus 1, bam. And then just because I want to make sure I didn't make a mistake graphing, I'm going to just backspace, put as a relation, and then put y plus 2x equals 6, and press enter. All right, so I can't see where they hit. And the easiest thing to do, by the way, to get the grabbing hand thing, what you want to do, I can drag and move this around. You can do that on your calculator too. What you want to do is put your mouse pointer right here, click the center button and hold, and then just your hand will turn into a thing that looks like this. It means like you've grabbed the paper and you're just going to drag it down. All right, so there's the point of intersection. Let's see if we can find it. Analyze graph, intersection. Click on the right, click on the left. There it is, negative 1, 8. So we got it. We nailed it. All right, now we're going to go back to algebraically. So let's see. It looks like, can you see what you need to do here? Which variable can we get rid of? I think we can multiply this first equation by 2. And that will give me 4x here, which is good. So 4x plus 2y equals 10. Negative 4x plus 6y equals negative 2. I get 8y equals 8, so y equals 1. Now, the first equation appears to be an easier equation to deal with. It doesn't have any negatives. It's all positive. And I got plain old y by itself, so that's good too. So 2x plus y equals 5. 2 times x plus 1 equals 5. 2x equals 4, so x equals 2. Now, even if these things are algebraically, it doesn't mean you can't graph them to check the answers. That's certainly a possibility. Right, you just put them both in as, I can't figure out why I can't erase. Okay, put them both in as the relation. So I'll come over here to graph mode. By the way, you notice when you put them in as relation, everything's blue. It's always blue. So I'm going to backspace, choose 6, 2x plus y, 2x plus y equals 5, I believe. Press enter. And then negative 4x plus 6y, so tab. Negative 4x plus 6y equals negative 2. Oops, I just made a mistake. You can see right now, this is not a negative, that's a minus button. So we'll put a negative in there and press enter. So that's where they hit. We said the answer was going to be 1, 2. It looks like it's 2, 1. Hold on a second. Menu, analyze graph, intersection, click, click. Oh, it's 2, 1. Oh, yeah, that's right. X comes before Y. So my point of intersection is 2, 1. X, then Y. All right, one more. Oh, we got a few more. All right, a little more practice. Well, I know what the second one looks like. So that's going to hit all the corners of all the boxes going up this way. And this one's going to hit all the corners of all the boxes going this way. And then this one, because the vertex here is 0, -4. This one, I'm going to bring the x over so I get y equals -x plus 1. And that's coming down like this. Yeah, that hit that point right there. And that graphs it like this. My goodness, I can't do that. So my point of intersection is this point, which is 1, 2, 3, -2. Just checking to make sure I didn't screw up. There it is, 3, -2. Oh, man. This one says, my graph over here says I'm a little bit off. So let me take a look and see what this one should be. Make sure I hit all these corners of all these boxes. And this was -x plus 1, so that starts here. Yeah, no, that's the right answer. Okay, I think my graph over there is wrong. So my graph, my answer key is wrong. And I thought I got rid of this problem. Whatever. Easiest way, it doesn't matter. Let's multiply by -6, less. So -6x minus 6. Pay attention to details. -6y minus 6x equals. Now, -6 times 500 would be -3,150. So -3,150 is equal to 8y plus 6x equals 3,580. So I got 2y equals, let's see, that's 30. 430. So y equals 215. Now, what do you think? How'd I do? Did I do a good job? Did I make a mistake at all? Do you feel like I made a mistake at all? Just rushed right through it, jammed right, go. Did I do all right? All right, this one I did on purpose, kids, because that happens a lot. Everything's all set up, ready to go. You just start jamming through it. But you forgot one of the things I told you about earlier, and that is that your variables have to be lined up. Otherwise, it does not work. So you have to start with that idea. Otherwise, whatever you solve is not correct, right? This should really be x plus y. So then we'll multiply by -8, that first equation. So -8x minus 8y equals 525. And 8x plus 6y equals 3580. And again, that now I just made a mistake that I didn't mean to make. The first one I meant to make, but this one I didn't. Remember, we're going to take this whole equation and we're multiplying it by -8, right? Just so we get this stuff over here to happen. So these cancel. But I forgot to multiply this times -8. So let's see. 8 times 500 is 4,000, -4,200. So I get -2y equals let's see, 200 plus 420. So 620. Is that right? -620. Yep, divide by 2, and I get y equals -310. What do you think? Did I do okay? Did I? Did I make another mistake? See, it's so easy to make sign mistakes on these things. Look at this. I didn't divide by -2, which means I got a -310. The answer is actually +310. We're so far off but we didn't even know it. So pay attention to your signs. Be careful with your signs. All right. Now the first equation is x plus y equals 525. We'll put the y in that we actually finally got. 310 equals 525. Subtract to get x equals 215. I know we got 215 earlier, but I'm pretty sure we got y to be equal to 215, not x, right? So you got to be careful. All right, let's take a look graphically. How many I got left? 2? I can do these. All right, let's do this one. So this one here has a vertex of -4, -1. It's going down with a rate of change of -1. So -4, -1, right behind my head. And it's coming down. By ones. Man, that's tough. All right, this one here is just y equals x minus 1, right? We tag that over here. So my y-intercept is 1. And my slope is 1. I could hate each other that way. That's weird. This rate of change is -1. It's coming down, right? But this rate of change is 1. They'll never hit each other. These two things will never hit each other. And when two things never hit each other, the answer is the empty set. Just an empty set of braces is all you need to do. Now, I got a problem. I hate fractions. No, I actually don't, but I know you do. So we're going to get rid of this fraction by multiplying through by 3. Now, when we do that, the second equation is going to change. So the first equation stays 3x plus 3y equals -1. But this whole thing is going to get multiplied by 3. You'll see why. 12x plus 3y equals 8. Now, had I been smart, I would have said, oh, hey, multiply through by -3, because then this would be negative. But the most importantly, this would be negative. And then, of course, this would be negative. So then these go. So I end up with here is -9x equals -9. Divide by -9, I get x equals 1. All right, we're almost done. Do not put it back in this equation. We're going to deal with this one. So 3 times 1 plus 3 times y equals -1. This is 3, so we'll subtract 3. So I get 3y equals -4. And then we divide by 3. And we get y equals -4 thirds. So this answer is 1, -4 thirds. All right, that should all be review. That is solving systems of equations graphically and algebraically. We'll do way more with this later on this year. But for now, hit that subscribe button, hit the like button, the thumbs up, and I will catch you all on the next video.